Welcome back, students. In this class we study the area related to circles, chapter 5, exercise 5.2. Before moving on to the problem, we'll study some of the definitions. What is a minor segment, major segment and a chord? So here a circle is there with center O and a line AB and 2 points here P and Q. So first we'll see this AB is a chord of the circle. So what is AB? AB is called chord, CHORD, of the circle with center O, here. So this is the first point. Next is, and this shaded region is called minor segment. The whole remaining part is called as a this one is called minor segment and the remaining part is called the major segment. So we'll see what is APB. This one's APB is called as segment. So it is a segment of the circle. So next one is, again we have AQP. So AQB is called as another segment. We can write it as, or we can segment. Here we can write it as minor segment. Here another segment is also, we'll just write segment of the circle. Segment of the circle, that is just bracket, we can write it as major segment. So this is formed by the chord AB. So this is minor segment. So next is, so here only I have written, no need to show this. ABP is the minor segment and AQB is the major segment. So this is about this circle segments, and this is the line chord, and we move on to the problem. That is the fourth problem. So we can also say this one, formed by, is a segment of the circle formed by the chord AB. So this is the definition of minor segment, major segment and the chord. So we go on to the problem. So see here in this question also we study about the chord. A fourth question, a chord of a circle of radius 10 centimeters subtends a right angle at the center. Find the area of the corresponding, first is minor segment, next is major segment, and area of the minor segment, that is OAPB. So this one is the problem C. This is the, so the chord is this one, 10 centimeters, a chord of the circle of radius 10 centimeter, subtends right angle at the center. So find the area. First one, see here 1 point and here also 1 point, PQ. So we'll start the problem. What are the details given? Data given. Radius is given as 10 centimeter. Angle at the center of the circle is theta. So angle at the center of circle is theta is equal to 90 degrees. So since right angle, so it is 90 degrees. So next is, first is, we have to find out the area of the first point. For the first sub problem is area of minor segment. So area of the minor segment OAPB. OAPB. So this is the formula given as theta by 360 into pi r square. So what is theta here? 90 degrees. So by 360 into pi into what is r? That is radius square. Radius square. So we'll simplify this. Pi is taken as 3.14. So we'll get, that is 550 by 7 will get this one is equal to 78.5 square centimeters. So we got the area of the minor segment as 78.5 square centimeters. So this is the fourth sub problem, first one. Next we move on to the second sub problem. That is the area of the minor segment, APB. So once again I have drawn this the diagram again. So this is the same thing, but I have written here. That's all. So area of the minor segment APB. So this one we have to find out. So now the equation we have to write is area of OAPB minus area of OAPB minus area of AOAB. Area of AOAB. So this one, anyway, we got area of OAPB as 78.5 centimeters square minus this one is area of this area of AOAB. So off into OA into OB. Off into OA into OB. Therefore 78.5 minus off into what is OA? OA is 10, OB is 10. So this is equal to 78.5 minus 2 answer to 5 we get 50 we are getting here. So this is equal to 28.5 square centimeters. So this area, that is OAPB minus the area of this one, that is OAOB, will be the area of the minor segment, that is APB. So after this we move on to the third sub problem, area of the major segment A. Here only we have, that is AQBO, that is AQBO. So next the formula for this is theta by 360 degrees into pi r square. Therefore what is theta here? Theta we should write here 360 minus 90. So this one is 360 minus 90 into divided by 360 into pi into what is r? R is 10 square. So after this, so what we get? 360 minus 90 is 270 by 360 into 3.14 into 100, which is equal to, simplify this, we will get how much? 235.5 centimeters square. So what is the answer? That is 235.5 centimeters square. So this completes the fourth problem. We move on to the fifth one. The fifth problem we have, in a circle of radius 21 centimeters. This is a circle of radius 21 centimeters and an arc subtends an angle here 60 degrees at the center. First one, find the length of the arc. We have to find the length of the arc, area of the sector formed by the arc, and also area of the segment formed by the corresponding chord. So we will take the first part, that is the length of the arc, that is OAPB. So length of the arc, that is OAPB. So therefore, sorry, this one OAPB. This is the arc. Okay, the length of the arc OAPB. So we have radius. So radius is given as 21 centimeters, and what is the angle of the center of the circle? Next is angle at the much theta is given as 60 degree. Center of the circle, theta is equal to 60 degrees. Next, we have to first find out the length of the arc OAPB. So we'll start this one. What is the formula? That is theta by 360 into 2 pi r square, 2 pi r. So now next is 2 pi r, therefore we have theta by, what is theta? 60 degrees. 360 into 2 into pi is 2 into pi, we have 3.2 or 22 by 7 into how much? That is 21 square. So what we have, theta by pi into 2 pi r square. So therefore 60, so simplify all this, we'll get 66 by 3, which is equal to 22 centimeters. We'll simplify this, 2 pi r square, angle of the center of the circle, major segment, and so we found out the length of the arc of the OAPB is 60, that is 66 by 3. But once again we'll see. Okay, substitute this, we'll get this one. So next is, we'll move on to the second question and the fifth problem. So this one formula is just pi r, I think. I'll just clarify the next class. Yeah, this one. Fifth one, first what we solved is pi r. So take it as r. So simplify and see. This is correct. So we are finding the length of this arc. So this is the formula. So any doubts, I'll clarify the next class. Okay, next is, we move on to the fifth question. That is the second sub problem. So here also I've written the again diagram, same thing. So we have to find out the area of the sector OAPB. OAPB area. Now we finished finding out the length of the arc. Now we are finding the area of this OAPB. So for this we have the formula as we know, theta by 360 into pi r square, So the 60 degree by 360 degree into pi is 22 by 7 into 21 the square. So now simplify this. So we'll get, that is 231 square centimeters. So this is the second problem. Now we move on to the next one. That is the last part of the question. That is the fifth question. So area of the segment, that is APB. So area of the segment for APB. APB. So for this we have the formula, that is area of sector. Area of the sector, everything I explained in the previous classes. OAPB. OAPB, area of this sector, minus area of the equilateral triangle, this one. Area of the equilateral triangle OAB, this one. This minus this, what we get? Area of the segment APB. So for this we got the answer as area of the sector as 231 minus root 3 by 4 a square is equal to 231 minus root 3 by 2. A square is 21 the square, which is equal to 231 minus this one will be root, that is 441 into 1.73 by 4. Next is 231 minus 190 by 9, which is equal to 40.3 square centimeters. So once again we'll have the fifth question, that is in a circle of radius 21 centimeters, an arc subtends an angle of 60 degrees at the center, and first is the find the length of the arc, second is the area of the sector formed by the arc, and the third one is the area of the segment formed by the corresponding chord. So these are the datas what we wrote, and this is the circle, and this is the triangle, and this is the space here, and this one is 21, the radius is 21. So what is the first question? The length of the arc OA, this one is OAPB. The length of this arc we have to find out. Radius is given, and the angle of the center of the circle is given as theta as 60 degrees. So what is the formula? Theta is equal to 360 into 2 pi r. So 2 pi r we substituted here, and we got 66 by 3, that is 22 centimeters. So next is the second part of the question, is the area of the sector OAPB. OAPB is OAPB. So we have to find out the area of this, which is equal to theta by 360 into pi r square. So substitute the values. Theta is there, that is 60 degrees, into radius is 21 centimeters. Then simplify this, we'll get 231 square centimeters. So last part of the problem, fifth problem, is area of this segment, area of the segment APB. So for this, to finding the area of the segment APB, area of the sector OAPB minus, means this whole thing, minus this one. So area of the equilateral triangle that is OAB, this one, this minus this one. This will be the area of the segment, this APB. The whole thing minus this will be equal to this. So substitute the value what we got in the previous part of the question is 231 minus this one is root 3 by 4a square. That is area of the equilateral triangle is root 3 by 4a square. Substitute the, what is a square? That is 21. A square means the radius given there, 21 square. So simplify this, we will get the answer as, that is 40.3 square centimeters. So this is the solution for the problem 4th and the 5th. If you have any doubts, comment me, subscribe my channel, share and like all the videos. Thank you.